We're continuing today studying adding integers. I have a second model that I'd like to show you today. The chips will still work. We're doing the same type of problems, but you might choose to use a number line because they're a little bit easier to use. They're smaller. You can make one on your own and do it on any piece of paper. You don't have to carry around lots and lots and lots of objects for bigger numbers. Before I show you the problems, let's talk about a couple things. You know that 0 is smack dab in the middle. It is neutral. It is the only number that does not carry a sign. It is neither positive nor negative. If I was to fold the number line on 0, 1 and -1 would match up exactly. They're what we call opposites. They're the same distance from 0. If I was to put a blob of wet paint at +7 and fold it here at 0, that blob of paint would match up with -7, its opposite on the other side. You know that the positives go to the right and the negatives go to the left. I want you to start to think about the signs as more of a direction. We're going to go in the direction of positive or in the direction of negative. All right, that being said, let's start with our first problem. We're going to do 7 plus 2, which is a very basic, easy problem. You've been doing it for many years now. You already know the answer, which is awesome. Use that to learn how to do this method. You will always start at 0. Now, there's no symbol in front of this, so we're going to assume that it's positive. It's one of the few safe assumptions that you can make. This tells me to go in the direction of positive 7 jumps. So if I start at 0, I'm going to go in the direction of positive 7 jumps. I'm just going to make an arrow. Now I'm going to add to that 2 positives. So I'm going to continue in the direction of positive 2 more from where I left off. Now, if you think about our chip model that we used the other day, we would have 7 black and 2 more black and put them together and get a pile of 9 of the same color. That's kind of what we did here. We went in the same direction both times, and we ended up at +9. I won't put the plus sign because it's not necessary. That's overthinking a problem that you've been doing for many, many years. But if you followed that, I think the next couple problems are going to be easier. Here's our next problem. -3 plus -2. Sometimes you'll see the parentheses around the second number or even the first number because they're trying to highlight that this is a negative sign and not a subtraction sign. The parentheses don't do anything else. It's just an extra notation so that it's very clear what the symbols mean. So we're going to start at 0 like we start every problem. This tells me to go 3 in the direction of negative, which we know is to the left. So I'm going to come this way, 1, 2, 3. And then it tells me to go 2 more also in the direction of negative. 1, 2. We ended at -5. If you think back to our chips, this would be 3 red plus 2 red, all together in one pile, 5 of the same color. And since they were red, we call it negative. Now, those 2 examples were the same sign, which means we were moving in the same direction. But what happens when we've got numbers with different signs? So this says 9 plus -4. I'm going to start at 0, like every problem does. I'm going to go 9 in the direction of positive. So I'm going to go to the right and stop at 9. Now, from this ending spot, I'm going to go 4 in the direction of negative, which means I'm going to backtrack 1, 2, 3, 4, and I ended right here at +5. And you look at that and go, well, wait a minute. I was adding and I ended up with less than I started with? Well, yeah, because you were going back the opposite direction. If you think about the 0 pairs that we used when we did the chips where we had 1 red and 1 black, this overlap right here is the same thing as your 0 pair. You've got enough to cancel out 4 of the originals, and then you're only left with 5 of the originals. All right, now I want to show you these side by side. The next problem has the same numbers, but the signs are different. We start here with a positive and a negative. This one is reversed. This is a negative and a positive. So let's see how that changes things. We start at 0 like every problem does. We're going to go 9 in the direction of negative, which is to the left. So we come all the way down to negative 9. And then I'm going to go back 4 in the direction of positive from where I stopped. So we'll come back 1, 2, 3, 4. I ended at negative 5 because, again, these are the same as the 0 pairs. The overlap or the extra kind of cancels each other out, and what is left is my answer. Now, let's compare these because this leads into our final technique tomorrow. So we had 9 and 4, we got 5. We had 9 and 4, we got 5. It's the signs that are different. So let's look at this. 9 was the bigger number, bigger quantity, bigger pile, bigger distance from 0. And 4 was the smaller number, smaller pile, smaller distance from 0. And my answer was positive. Let's look at this one. 9 was the bigger pile. 4 was the smaller pile. And my answer was negative. I'm not going to give you the rule just yet, but you might start to see some patterns the more you look at these. If you'd like to use the number lines, you can draw one on a piece of paper. You don't even have to put the actual numbers on. You could just use a number line like this. Say, okay, here's my 0, and I'm going to go this way to 10, and then this way, so it's 3, and we'll end up back here at 7. All right, you'll get really good at little shortcuts like that, still being able to use the number line, especially for bigger numbers. When you get into, double digits and in the hundreds, you don't want to be carrying around chips and little counters. That's way, way too much. If the counters are better for you, you have access to those on Google Classroom or you have some with you, you can certainly still use the counters.